great weekend. Just wanted to bring something to your attention before we start in on today's topic. As you hopefully saw in my little update that I post every Monday, next week is our first exam. So that first exam honestly kind of snuck up on me, to be completely honest with you. But yes, it's here already. Next week is going to be the first exam. I know for a lot of you this will be your first computer science exam, so there might be a little extra level of anxiety because of that. So, there's stuff to help you. I've posted some resources on Canvas to help prepare you, to help you study. There's tons of practice questions and a little, well, it's not little actually, it's quite large quiz on Canvas. There are some coding problems that are also available for you to take a look at. And next week, in this very room, at this very time, I will be leading an exam review session. So next Monday's class is devoted to prepping you for Thursday's exam. I don't really want to get too much more into the exam stuff today because I want to make sure we devote an appropriate amount of time to our topic, but I just wanted to make sure it was on your radar because it is coming up. Make sure you're aware of all those resources and ask you to come next Monday with plenty of questions. I would love to help you study for next week's exam. Are there any questions I can address without getting too much into the weeds right now about the exam before we hop into today's topic? Yes? What topics will be on? 1 through 3, yeah. Yep. Alrighty. Let's go ahead and jump into today's topic, which is arrays. Arrays is our topic for this week. Actually, before we hop into arrays, I want to take a moment and tell you another interesting fact that you may not actually believe, but is 100% true. Knowing what you already know, so variables, loops, if statements, it is true. It has been proven mathematically that you can write any computer program that could possibly be written. Yeah, for sure. You could write any computer program that could possibly be written knowing those things. Variables, for loops, and if statements. Actually, you don't even really need loops because you can always just copy and paste the same chunk of code over and over and over again. So technically, you don't even need loops to do it. You just need if statements and variables. Surprising fact, but very true. The next question might be, what the heck are we doing here then, right? Can we all just go home and call it a day? Not really. As you might imagine, writing big complex programs gets to be very difficult. If you only have those tools at your disposal, it's like trying to build a house with only a hammer and nails. So yes, those are some tools that you need to build a house, but I would imagine you probably also need a saw and lots of other stuff as well. So it's not the end of the road by any stretch. A lot of the concepts that we're going to teach you going forward are just ways to help make our interactions with the computer even easier, even simpler, to try and match the real world stuff that we're used to as much as we possibly can in the form of our computer code. So just wanted to kind of drop that little knowledge bomb on you before we hop into today's concept, which is arrays. So arrays are a very useful structure, and to understand why we need them, consider a very simple application where we want to track the temperature, the high temperature every day. We could easily think of doing that for a week, right? We would just make 7 variables: Sunday, Monday, Tuesday, Wednesday, and even a couple of weeks, that's 14 variables, right? If I want one for each day that I'm trying to track in my code, right? But if I do a few months or a few years, right? Things that are certainly well within the capability of the computer to do. I guess very tedious for me as the programmer to have to create individual variables for those things, for each of those individual values. Like, it's very tedious for me. Also consider the fact that there's a relationship between those values. Those values are what I would call a collection of things, right? That are all kind of part of a group that are related to each other. So arrays are the first example, but not the last, of a collection of things that we're going to see in this class. Actually, we, as computer scientists, love these kinds of things so much that we have a whole course dedicated to them called data structures, which is the one that's right after this one. We love to think about how data is stored on the computer. Turns out that how you store the data makes a big difference when it comes to how the programs work. So that's a kind of a watered down version of it, but yeah, very true. So arrays are one of the simplest data structures that we can introduce people to. And let's go ahead and dive right into some code and take a look at how we can use them. First thing we have to do is we have to create an array. So this is a review, but I'm going to ask you anyway, right? This is called a variable declaration. That's right, I heard somebody say it, right? Variable declaration consists of two parts. This is the name, and this is the, I think I heard somebody say type over there. That's the right answer, yeah. But this type is one that you've likely not seen before, or at least not exactly in this way, right? We've seen int before. We haven't seen these square brackets before today. The square brackets, that's our clue that this is an array. This is a collection of integers. It's not just one thing, but it's multiple things. And so then on the right-hand side of the equal sign, we get a little bit more information. Over here I see the int brackets again, but this time there's a 10 inside of those brackets. And as you might suspect, that tells us how many ints this array can contain. So arrays are somewhat inflexible in that once I've created this array with 10 things in it, that's it. It cannot later on be 9 things or 11 things or any other number of things. It will always have 10 things in it, always, from the beginning to the end. If I really want to change it, I have to stop the code, change the code, and then start it over again, right? And you might learn some little hacks and techniques to work around that restriction as time goes on, but arrays are not able to be resized once they've been created. That's it. That's how big they are, period. So if we run this code, I think we'll see that we can access some information from our arrays. So later on, right, we can retrieve this value back from our array by using the name of the array followed by .length. And this might seem a little bit trivial to you now. You might be thinking, why would I do this? You just told me it was 10 right there. Very silly. Could just easily have said that. But it turns out this is a very useful piece of information for us. And so one thing that I would like for you to consider is that the type of the array can be any of the types that we've seen up until now. So if I want to make an array of doubles, right, called prices, I can say new double, and they want 5 things in it, all right? If I want an array of strings, right, a single string, I would say, string name. But if I want an array of strings, I put the square brackets after it. It is now an array of strings, a collection of strings called names. And I can create this as well. Okay? Now these are creating what I would call empty arrays. So if I actually looked inside of this array, remember I told you there's 10 things in it. What are those 10 things? Well, for an integer, it's empty, and empty means 0. It's all zeros. It's just filled with literally nothing, right? If it's doubles, same thing. It's going to be all zeros in there. String, it's going to be the empty string. We actually talked a little bit about the empty string last week in class, if you remember. So chances are that's not what I want. Maybe sometimes that's what I want, but most of the times I want to have stuff in the array. So there's a way we can create arrays where I can actually set those values to be something besides 0 in this case. And so this is what we call an initializer list, where instead of creating an empty array with all zeros in it, we're saying create an array with these values in it. Notice the difference of curly braces here as opposed to square brackets. So if you know what data you want your array to have, you can use the curly brackets. If you don't, think about when you might want to use this. What if I'm about to ask the user to type in a bunch of numbers? I can't predict those ahead of time, but I'll create this empty array and then I'll put them in there as they type them in. So there's a time and a place for both. Let's take a look actually at this line, which might seem a little bit simple or trivial at this point in time. It looks like it, oh, actually it's just printing out the length of the array. What I wanted to show you is this. What if I just print out the array? What if I just print out the array itself? What? I tried to print out my array of high scores. I told you that those values were going to be in there, but when I tried to print it out, it's like that. That's necessarily what most people would expect in this situation. Turns out that printing out an array like this isn't quite the proper way to go about it. We need to have a way of accessing each of those values one at a time, and then printing out each of those values one at a time. That's kind of a little sneak preview of what we're going to be getting to next. Before we do that, though, let's take a look at how we can access those values one at a time. We need to provide some information to the array. If we look at this line right here, well, let me not skip anything. We're creating an empty array. So this array will be filled with all zeros, right? If I look at a line like this, specifically the stuff inside of the parentheses, this is the first example we have seen of using an index. So the number that is inside of those square brackets I would call an index. And I want to be a little bit careful. This is not an index. This is the size of the array. That is how big the array is going to be, right? That only happens once, at the very beginning when we first create the array. But anytime you see a number inside of the brackets after that, it's going to be something called an index, where it's saying, give me the value at this position. You might be thinking, why does it say 0 there? That's a little bit of a weird place to start. In computer science, we actually do start counting from 0. And to understand why that is the case, you have to think a little bit about how the computer sees the world. What that index really means in practice is how far away from the beginning of the list is the item that I want. So it's the very first item in the list. How far away is it from the beginning of the list? 0. It is the beginning of the list, right? It's the very beginning. How far away is the second item? Well, it's 1 away from the beginning, right? So the index is a little bit off in terms of how humans think about things, but the first item in the array is at position 0. The second item of the array is at position 1. The third item in the array is at position 2, so on and so forth. And so perhaps the most important item to think about is the last item. There are 5 things in this array, but the position of the last item is 4. Right? 0 consumes one of the 5. So 0, 1, 2, 3, 4. That's 5 things, right? But there is no position 5. And I'm saying that now, and I'm probably going to say it a lot more as time goes on today. And for good reason. It gets people into a lot of trouble when working with arrays. They forget about that shift, that little shift. But that's a very important fact to remember. If the length of my array is 10, the position of the last value is going to be 9. So always 1 less than the length, right? Always 1 less. So we always start at 0 and we go up to, but not including, the very last element in the array. So here we'll see, we're going to print out the 0th item. That's how I would say that. The 0th item of the array. It should be 0 at first because the array is empty up until that point. We then write this code to change all of the values and print it out again. After that, it should be 99. This is a variable assignment statement. We're saying take the value on the right-hand side and store it in the place on the left-hand side. So take the value of 99 and store it in bucket 0, index 0. Right? I really sometimes visualize in my brain an array is just a series of actual buckets. Right? Take the 0, or take the 99 and put it in the bucket marked 0. That's what's happening in that statement. Take the value of 98 and put it in the bucket labeled 1. That's what's happening in the second statement. And so on and so forth. So if we run this code, we'll see 2 print statements. The first one shows me the empty value of 0. The second one shows me a 99. And the nice thing about this program is you can try this with any of the values of the array. So 2 will still be 0 at first because the array is empty. But then after I print it out, I should get the 98 from the array. Like so. All right. And then one final technique before we move on to our next topic. I want to introduce this idea of parallel arrays. So perhaps you've noticed, perhaps you haven't, that the type of an array can only be one thing. So if I make an array of integers, the only thing I can put in that array are integers. I can't put doubles into an array that I've said is going to have integers. It won't work. It won't let me do that. This can be a problem because sometimes I have data that is of multiple types that I wish to keep track of. But to get around this restriction, we can use what's called parallel arrays. So this is an example of parallel arrays, where I create an array of integers that represent scores and an array of strings that represent names. And when using parallel arrays, there's the intention is that the arrays sort of overlap with one another. Or another way of thinking about it is that the index is sort of the glue that ties these parallel arrays together. In other words, the name in position 0 is who got the score in position 0 from this array. So they're parallel, right? The name in position 2, Destiny, got the score that's in position 2 from this array, and so on and so forth. So using this, right, we can create multiple parallel arrays. We're not just limited to 2, although that's pretty common, to be honest with you. You're going to see this technique coming up in a future lab or studio, more than likely. So it's one of the reasons why I wanted to introduce it to you here today. Any questions with me before we hop into our next array traversal topic? Okay. So earlier I showed you what happened when I tried to print out an array by itself. I can actually show you in this example too, just to kind of refresh your memory, even though it was just a moment ago. If I try to print out the array directly, names, it doesn't work. I actually get what looks to be a load of gibberish. It looks to be just a load of junk. I actually know what this is, and if you're curious about what this is the memory address on your computer at which the array lives. So quite literally, you think of your computer as having numbers on all the addresses, right? That's it. If your number is the same as mine, then we should go play the lottery together or something. I don't know. Like, that would be unheard of. It should be very unique to your specific machine. But that's not what we want. That doesn't help us. That doesn't even help me. I do a lot of coding. Never have I said, oh, this is the information that I want. Never. That doesn't happen. What I want is to see the contents of the array. So in order to do that, we got to bring in something that we showed you last week. Got to bring in a loop. Notice, in particular, it's a for loop. For loops and arrays go very, very well together. I'm not going to say you're never going to use a while loop with an array. It could definitely happen. I'm sure I've done it. But for loops and arrays go very, very, very well together. And this is a classic for loop, one that you'll see time and time again, where I, our loop variable, is set to be 0. That makes sense because arrays start at position 0. So I, in some sense, you can think of as being short for index in this particular case. I is going to be less than, but not equal to, the length of the array. So think about what that means. We know that if this is the size of our array, or the length of our array, the last position is going to be 1 less than that. And using strictly less than to compare takes care of that for us. Make sure that we don't go too far. Right? Although, I'm going to be honest with you, sometimes we still go too far. Sometimes we still make mistakes and go off the edge of an array. I'm going to show you what happens when you do that a little bit later on today. But we don't want that to happen, so this is a nice way to avoid it. And then I is going to go up by 1 each time. Think about the values of I as we go through the loop. Starts at 0, goes up by 1, so it's going to go 0, 1, 2, 3, so on and so forth. Every time through the loop, I is being plugged in as the index. So the first time through the loop, I is going to be 0, and I'm going to grab the item at position 0, and I'm going to print it out. The second time through the loop, I is going to be 1. I'm going to grab the item at position 1 and print it out. And so on and so forth. And the result of that you can actually see from my execution of this program earlier, does what we hope to see, prints out the contents of the array. Are there any questions about this? This is classic. You're going to see it time and again. Yes?
So the I less than names.length, that restricts our index so that it lines up with the amount of like inputs in our index that
Yep.
you have in each string.
Yeah. there's a few ways you can verify this yourself if you need some extra convincing about what's going on here. One of them is simply, let's just print out I as we go along and see the value of I as we go through the loop. So we see the value of I followed by the name at that position. So 0 is Jamal, 1 is Emily, 2 is Destiny, 3 is Mateo, 4 is Sophia, and then that's it. Nothing else happens. But let's go back and do a little bit of more experimenting, because, you know, why not just try what happens if I do less than or equal to, right? Like, what's the worst that could happen? The worst that could happen is this. We run our code and I get this red text. Maybe some of you have already seen something like this or something similar to this perhaps. This is a classic error. If you haven't seen one of these yet, I almost guarantee you will at some point in your coding career. I still run into these problems all the time, right? The important thing is not necessarily avoiding these issues. The important thing is, what do you do when you run into one? How do you get unstuck? How do you look at this red text and say, oh, I think I know what the problem is, let me go fix it? That's really the important thing. So let's see if we can take a look at this and try and figure out more about what's going on. It tells me array index out of bounds. So that literally means that the index has gone off the edge of the array. I've gone too far. This almost always happens on the far end of the array. Most people can remember we start at 0. Plugging negative numbers in is kind of silly. That never happens, although that would lead to the same thing. But more often than not, it's because we've gone off the far end of the array. We've gone past the end. We should have stopped sooner. And it tells me index is 5, out of bounds for length 5, which again might seem like a silly statement until you remember, oh yeah, my arrays start counting from 0. So the last address isn't 5, it is 4. So it's telling me I tried to plug a 5 in, but there is no position 5. The last position is position 4. It'll even give you more information, right? This right here, this is the name of the file that I'm in, and this number is quite literally the line in which this error happened. And if you click on it, it'll take you right to it and say, oh, this is the line where this error occurred. And then you can look at this and be like, huh, in order for that to have happened, I must have gone, too far. Must have gotten too big. Oh yeah, I should take the equals sign off. Right? That's a classic off by 1 error is what it's known as. Yeah.
Could you say what the I plus stuff?
Sure. Okay. Yeah. Sure.
Up the array, or is it?
It actually doesn't touch the array. It touches the loop variable. I can rewrite this though as I equals I plus 1, if that maybe helps illustrate a little bit better. These are equivalent. If I run the code, it'll work exactly the same. And honestly, if you feel better writing it this way on the exam next week, awesome. No problem with that whatsoever. That's totally fine. Yep. Any other questions I can address? Yeah.
What's the significance of the point length after names?
Okay. So I'm going to try and maybe read into this question. The question is, what's the point of this, right? Maybe I'm going to try and read into this question maybe a little bit more like I could just say 5 here, right? Is that kind of what you're getting at? Or I'm not sure. I mean, this is telling us how I is controlling how many times through the loop we go. We want to go through the loop 1 time for every item in the array. How many items are there in the array? There are names.length items in that array. That is how many.
That just counts the amount of items that are associated with names.
Correct, yes. And actually, maybe I glossed over this fact a little bit earlier on, which might explain your question. When I create an array like this, it literally counts. It says 1, 2, 3, 4, 5. Oh, the length is 5. But to be, even more direct about it, right? Like, I don't care what this number actually is most of the time. I don't care if it's 2 or 7 or 100, right? I just want to know how many things are in my array. So this is how we do that. Yeah. Great question. Thanks for asking. Any other questions that I can address before we move on to the next example? All right, cool. So, yeah, if we take a look at something, that's an off by 1 error, so I already did that. This trace doesn't actually have any loops in it. but it's still a good example. I want to show you actually this example right here. Last week I introduced you to two kinds of loops, and this week I'm going to introduce you to actually a third kind of loop, one that I like a lot, one that comes very much in handy, especially when dealing with arrays and other types of collections, because we're going to see some more collections later on in the semester, not just arrays. It is a for loop, but it's the official Java term for it is an enhanced for loop, or most people, myself included, just call it a for each loop. That's what I refer to it as. So the idea behind this loop is, what if we only care about the data? We don't care where the data is, right? Like, I don't care that this is in position 0. That doesn't matter to me. I just want to see this value, right? The for each loop lets us do that. So if I write a for each loop, instead of 3 parts, we're now down to 2. This is saying for each value in the collection called high scores. And so the first time through this loop, value is going to be 10. The second time through this loop, value is going to be 9. Third time through this loop, value is going to be 8, and so on and so forth. No indices. At no time do we touch the index, right? It's purely based on the data, the values. So these can be handy in situations when we don't need the index, of which there are many. There are other situations in which the index matters. What if I'm trying to move things around the array, right? Take things from the front, move them to the back, take things from the back, move them to the front. I have to know the index in that case. I have to have an index to pull that off. So in situations where the position matters, using the last example of a for loop like I just showed you is more appropriate. But in situations where it doesn't matter, this is an option to you. Not to say that you couldn't write it the other way if you wanted to. In fact, I think one of these examples is going to have us convert back and forth between the two. But to kind of make this a little bit more concrete, this first part is our loop variable declaration. I'm creating a loop variable, but instead of the index, this is going to represent each value. And the second part is a collection. So when I print this out, we'll see all of the values of the first array, high scores, printed out, followed by all of the values of the second array, called names. So there's my 4 integers, and there are my 4 strings. Notice that, making this a string would be kind of silly, right? High scores is an array of integers. So this thing is also going to be an int, right? Doesn't make sense for it to be anything else. If I'm writing a loop, however, that is based on the index, like the first example we saw, this will always be an int. The type of an index of an array is int. In fact, that is a question that has been on an exam in the past, I promise you. The type of an the type of an index into an array is int every time, and that kind of makes sense if you think about what an array is. If I try to plug in 2.7, right? Array has buckets. Array has a certain number of buckets. What is bucket 2.7? That doesn't make sense when you think about what an array is. Has to be an integer, has to be a whole number. Any questions about the for each loop style versus the not for each loop style? Yeah.
So are you saying that when you do an int value, are you basically setting each number inside of the array of high scores? You're just setting that to value, or are you assigning to value?
Let me do you one better and actually show you using the debugger. I'm going to set a breakpoint here on line 12 and hop into the debugger, and we can just see what value is as we go through this loop. I think that's a good thing. So here we are, the very first time we stop in this loop, value is 10. That's the first number. If I keep continuing, so there's the 10 that gets printed out. Next time through the loop, value is 9. So there's the 9. Next time through the loop, value is 8. There's the 8. And then last time through the loop, value is also 8, because that's the last value in the array. So it's taking on each one of these values. Now, if you want to, again, contrast that with this style of loop, right? I can set a breakpoint inside of here, and we can watch what happens with this loop. This is a good idea to do anyway. I is my loop variable. I starts out at 0. And so in order to understand what that means, in the debugger, if you want to, if you click this little arrow here, this is my array called names. You can actually expand it out, and it'll show you Jamal's at position 0, Emily's at position 1. So I is at position 0. It's going to plug that 0 in, get Jamal back out, and print that. Right? The next time through the loop, I is now 1. So I plug 1 in. I get the value from the bucket labeled 1. Print that out. And so on and so forth until I gets to be 4. I print out the last value. When I add 1 to 4, I get 5. 5 is not less than the length of this array, which is also 5. 5 is equal to, but not less than. So the array, this loop is now over, and we're out. We're done. Hopefully that helped. I know that was a long answer to your question, but any other questions I can get to? Yeah.
Do you have an array that has string values and integer values?
No. In order to pull that off, you'd have to use this concept of parallel arrays, where I make one array of integers and one array of strings. Now, to more completely answer your question, think about the fact that right now I'm trying to categorize almost everything in the world as ints, doubles, booleans, and strings, and that does work for a lot of stuff. But you know, there's more stuff in the world than just ints, booleans, doubles, and strings. It would be nice if I could make a computer type if I wanted to, or a person type if I wanted to, or a student type if I wanted to, that represents those things. And those are a combination of ints, booleans, strings, and doubles. We're going to get there. That's module 7. So don't worry about that for this exam. To answer your question, right, we can combine things together later on and then do kind of what you're asking. But for now, this is the way. Parallel arrays. All right. Let's move on to, I think we have another example. Yeah. I like this example. All right. Here's an example of iterating through an array using the first style of loop, an index, right? And I want to run this. It's got an if statement in here. What's this called again? This is a good exam 1 review question. Modulus, right? What does it do? Remainder after division. So this might look a little bit crazy, but think about what this is doing in human terms. If I ignore the array business for a second, I can just see I'm saying if the remainder after dividing by 2 is 0, that means 2 goes in evenly. That is quite literally the math textbook definition of an even number, right? If I can divide it by 2 and I have no remainder, that is an even number. So I'm looking for even numbers. I'm trying to skip the odd numbers and look for the even number. If I was looking for odd numbers, right, what would I do? That's a pretty simple tweak, right? Just switch that to 1. And now I have a way to filter for odd numbers instead. But we're looking for evens in this particular case. What are we looking at to check to see whether it's even or odd? This stuff right here. This stuff right here. So I want to go through this array of values, and I want to look at each value one at a time and say, is it even or odd? And if it's even, I want to say that. And if it's odd, I just want to ignore it and do nothing. And if we run the code, that's exactly what's happening here. 6 is even, 2 is even, 12 is even. Those are all, in fact, true statements. Notice that it did not pick up the 1, the 7, or the 5. They didn't pass our modulus test. So it's going through the loop. Every time through the loop, it's checking one value to see if it's even. If it is even, then it's printing it out. If this fails, then we just move on to the next one. Everybody, we good so far? Yeah, question.
If you also wanted to print out that like 1, 7, and 5 are odd, would you recommend using an else loop for that? Or not loop, an else statement for that?
You could use an else for that, yeah, for sure, absolutely. I think this is the cleanest way. There are other ways you could go about it. Else works nicely because there's only two options. Either it's even or it's odd. There's no third option for it to be. If there was a third option, then we'd have to approach it a little bit differently. But yeah, an else would do the trick just fine. Great question. Any other questions? I think we kind of get this so far. What I want you to notice is that while this works perfectly well, we don't actually care about the index at all to solve this problem. I don't care, right, that this is at position 0 or that this is at position 0, 1, 2, 3, 4, right? I don't actually care about that. We use the position to help us figure it out, but we didn't actually have to. We could rewrite this as a for each loop, and that leaves the index out of it. It makes the solution, some people would argue, a little bit more clean, a little bit more direct. Why bring the index into things if you don't have to? So let's go back and switch this to be a for each loop style, which really involves just gutting the stuff in parentheses for starters. Int value in the collection called values. And now we no longer need square brackets to represent at all. And actually values, plural, is the array. We want to use the value, singular. That is our loop variable. In fact, these names are almost close enough to where I might try and change one of them a little bit just to make it even more clear. But that's it. We've done it. Replace the stuff in the parentheses. Tweaked any use of square brackets that exist inside the loop to refer to this loop variable. And now there's no mention of the index anywhere. We don't need it. We don't need it here. It's not necessary. If I run this again, we'll see that it works exactly the same. I get the same results back out. The loop that was here before and the loop that was here that are here now do exactly the same thing. Yes? Absolutely, absolutely. And let me Control Z, and I'll go back through it in a little bit more detail. I'd be happy to do that. This is how it looked before. This for loop, the one that we studied last week, has 3 parts. And by the way, before I delete this, I want to just say, if I asked you this problem on an exam and you wrote it this way, awesome, full credit, top points, right? Like never going to take off points because you decided to write things this way instead of a for each loop. That's not a thing. It's going to happen. Just want you to be aware of the for each loop style. So this stuff in parentheses is going to change. Instead of having 3 things, we have 2 things, and I'm going to make things look a little bit different this time just to really illustrate. Not equals, that was a mistake. It's a colon. So this is my loop variable. I'm going to call it V this time. On the right-hand side of the colon goes the array, the collection. This is now a for each loop. Eclipse is telling us that we have problems now. All of the problems are that I'm trying to use this index. Well, I intentionally rewrote the loop to take that index out of the picture. So the last thing to do is to consider that instead of saying grab the value at this position, we can just use it directly via the loop variable. So anywhere that we see square brackets inside of this, we'll just replace it with our new loop variable called V. Hopefully that was a bit more clear. Awesome. For extra practice on this problem, run it through the debugger both ways and convince yourself right that way that it's working the same way both times. That would be a good way to study this problem even further. Any other questions? Okay. Let's see. This one's going backwards. So this one's asking you to this one's asking you to take the for each loop and do it another way. But here's the problem though with for each loops. This is actually an interesting example. What is this loop trying to do? It's trying to take this array and just add 1 to all of these values. So after we're done, I want this to say 7, 3, 2, 8, 13. That's what I'm trying to do. That's what I want my code to do. Is just bump each of those numbers up by 1. So if we look at this for each loop, right, it seems kind of reasonable at first. Here's the Here's my loop variable, here's my collection, and then I say, all right, just add 1. Add 1 to that. But this isn't actually the value that's stored in the array, right? It's more like a copy of that value that's stored in the array. So the problem is that, even though we'll do the arithmetic correctly and compute what those values should be, they never actually get stored back in the array that way. So if I run this code, we'll see that all of the values get computed properly. There's 1 plus 6, right? 1 plus 2 is 3. So it's doing this properly, but the array after the loop looks untouched, as though nothing has changed. This one might actually be a good one to walk through the debugger with you to really illustrate why this doesn't work, because it's an important limitation of for each loops. Here I am on line 12, the very first line of the for each loop. I can see that the value is 6, but notice that the real 6 is here. I have two 6s, the one in the array and my loop variable, which is really just a copy of the one that's in the array, right? So when I add 1 to this value, it made the copy go up 1, but the value that's in the array has remained untouched. So I go through this loop thinking that I'm going to add 1 to each of the values in the array, but that's not what actually happens. I look at my array afterwards, and it doesn't look like anything's changed. So this is an important limitation of for each loops. They're great for looking at the values inside of an array. They're not so great for changing the values inside of an array. If we wish to modify the contents of an array, then we're going to fall back on this style of loop. Which means that we're going to change this to say values at I plus plus. This might look a little silly to you, but think about it step by step. I'm saying go to the value in the array at position I and add 1 to that directly, not the copy, but directly in the array itself. We can actually run this back through the debugger. I'm going to get rid of this line of code for now. I'll just comment it out and use the debugger to show this off. Ooh, right? Our loop variable I is no longer a copy of the values. It is now the index. So when I make these changes, you'll see that the values are changing directly inside of the array itself. Right? And then when I print out the array, notice, look, I'm still using a for each loop here. For each loops are great if all I want to do is look at the values in an array. So if I just want to print out the contents of the array, great. But if I actually want to change the values in the array, then using this style of loop is, I would even hesitate to say required. You can work around it. It just becomes clunky. Any questions? Yes?
Couldn't you have just like written E plus 1?
I'm sorry?
Couldn't you have written like E plus 1 after the for each loop? Would that have changed every single value of the array by 1?
Are you saying something like this? Or I'm not sure I follow what you're asking. You want me to put it back to the way that...
No. I'm saying like go all the way down to the end of your code.
Okay.
And then where this is about the print, and then you write E plus 1.
Right here?
Yeah.
So again, that would give me the right numbers at the end, but that won't actually change the values in the array itself if I'm actually trying to modify the data set itself, right? Then I have to do it the way I was showing it to you before. This doesn't actually change the data inside the array, so if I'm going on later on in my program and I use that array later, I'm going to see the wrong numbers because they didn't actually change the numbers in the array. Do you understand what I'm saying? Right? I can always modify stuff when I print it out. That's always true. But if I actually am manipulating a data set, a collection of data, that's an entirely different thing. Any other questions? Yes?
I know we just went over it before, but when it was printing the value of like where it was stored on the display,
Uh-huh.
what did you do wrong or what did I forget to add?
When it was printing where, so it does that, if I'm interpreting this, your question properly, which maybe I'm not. If I just try to print out the array directly, that's when I see this. So if that's what you're seeing on your screen, is that what you're asking about? Yeah, if that's what you're seeing on your screen, then that says you need a loop of some sort around that print statement. It could be either a for each loop or either one. But you need a loop. You can't just print out an array by itself. You have to print out each element of the array individually, one by one, using a loop. Yep. Yes?
And then the last line of the code, you just print the empty quotes.
This right here?
Yes.
So it's not quite empty. I know it looks kind of empty, but it's actually not quite empty. There's a space in there, and it matters. It actually matters. I can show that to you by just taking it out. What happens if I take it out? Smoosh. Yeah. Properly spaces the numbers so that I can see them. Computers are very literal. That's a great example of a computer being extremely literal down to the spaces in between numbers. Yeah. Yes?
Do H-loops have any applications outside of working with arrays?
Well, any collection, I would say. Like I said, collections are an important part of any program. So for each loops and collections go hand in hand, in my opinion. They're so useful, not just for arrays, but later on in this class we're going to see array lists, we're going to see sets, we're going to see all kinds of stuff. For each loops as well. Yep. All right, so I know it feels like maybe arrays are somewhat complicated. I'm going to be honest with you, this is one of the first topics that people really sort of kind of struggle a bit with. I know that week 2 is definitely harder than week 1. Week 3 is also trickier than week 2 in most people's experiences, but we're about to take things up one more notch, and this is the last notch we're going to take things up for today, I promise. But it is kind of a doozy. Let's think for a moment about the idea that the arrays we've been looking at are like a straight line, right? They're like a list of things. It's not necessary, however, for me to limit my collections to just a list of things. And if this were a math class, I would call this maybe a vector, a row vector, or a column vector, right? But you know, we like to do things in other types of math with things called matrices, which are rectangular in nature. And we actually have a similar kind of tool in computer science. It's arrays, actually. So instead of having a one-dimensional array that represents a vector, this example has what I would call a two-dimensional array. So a two-dimensional array is not just a single row or a single column, but it is in fact two-dimensional. It is rectangular. Rectangular in nature. There will be rows and columns. Two-dimensional arrays have rows and columns. And as a little bit of a side note, right, three-dimensional arrays, right, if you want to think about also a thing. In fact, if you're doing any kind of work with graphics, almost essential, because we're working in three-dimensional space, right? So three-dimensional arrays are definitely a thing. And why stop there? You know, we as human beings don't really think too well outside of our 3 dimensions. We like our 3 dimensions, but computers aren't limited by that restriction at all. So if we want to make a, I don't even know how many that is, dimension array, we can do it. However, not super common. Anything more than 3 is kind of unusual. Anything more than 2 in this class is not going to happen. You're going to see 2-dimensional, that's it. I'm not even going to throw 3-dimensional at you in this class. But upper level CS classes, yeah, you'll definitely start to see some higher dimensional arrays beyond 2. Let's talk about two-dimensional arrays. We've got rows, we've got columns. And so as you might imagine, when we create the array, we see two brackets. That's what tells me it's two-dimensional. That's what tells me it's two-dimensional. We also say that these are in row major order, which means that if I think about these brackets, this represents the rows and this represents the columns, or actually be more accurate over here. This first number represents how many rows, and the second number represents how many columns the array has. And that will always be true. The number of rows always comes first. Always, always, always. Before, we saw that if I wanted to see how many things were in the array, I could use array name dot length, and that still exists and that still works. However, it's not the total number of things anymore. It is now how many rows there are in a two-dimensional array, which we then have to think, okay, how do we get the number of columns out of a two-dimensional array in that case? And to think about it, right, here's the statement. Let's think about what this is saying. This is saying go to row 0 and tell me the length of that. The length of one row should be equal to the number of columns, right? If I just look at the first row and I say how long is that, that tells me how many columns there are. So that is how this statement works. This is a confusing one, though, and also, definitely something that I've asked about on an exam at some point in time, when you're going to see a lot. And so if we run this, right, we can see that as we manipulate the size of our array here, right, we can always get the number of rows and columns back. 6 rows, 2 columns. So yeah. The same thing is true as before, though. Right? We start counting from 0 for both rows and columns. So if I have 6 rows, that means that the last row is 5, and if I have 2 columns, that means that the first column is 0 and the last column is 1. Question?
What was the question so
Potentially all of it, if you're going to ask me questions like that.
But you said something about the last time.
This is the one that trips people up
Okay.
the most. Yeah. So this is how we create an empty array, an empty two-dimensional array. And as you might expect, this is going to have all zeros in it. So I would see 6 rows and 2 columns of zeros with this array. But like we saw before, there's a way that I can create an array that's already got stuff in it. We can initialize that array. So I believe, yeah, this is an example of that, right? There's our curly brackets again. Let me see if I can tweak the indentation to make this a little bit more understandable here, right? There's curly brackets upon curly brackets. So these represent the beginning and ending of the array. And then this is the first row, followed by a comma. This is the second row, followed by a comma. This is the third row. Notice that all of these have the same number of elements in them. For this class, that will always be true. I am never going to give you an array that looks like this, where some of the rows are uneven in length. In practice, you actually can do that. I'm just not going there in this class. You can safely assume every array that we see is going to be a pure rectangle, right? All the rows will have the same length. All of the columns will have the same length. That is always, always, always going to be the case. I got to be honest with you. Even though I'm aware that this exists, I can't remember a single time when I've been like, oh yeah, that's exactly what I need in this situation right now. I almost always use rectangular arrays, even though you don't necessarily have to do it that way. But yeah, this is how we create an array that has stuff in it. So how big would this array be? It would have 3 rows and 2 columns. But this is, what row number is this? 1. It's row number 1. This is row 0. This is row 1. This is row 2. Right? This is column 0, and Maria, Susie, and Luke are in column 1. And so here is a statement that we can use to retrieve a single item. Notice that it's not enough to just provide one index. I have to provide two indices for a two-dimensional array. One for the row and one for the column. So the very, 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 very first thing in the array is going to be at row 0, column 0. And I always think of the 0, 0 as being at the top left corner of my rectangle, right? 0, 0 is at the top left corner of my rectangle. It works well in this example, right? This is row 0, column 0. Jamal is what I would expect to get printed out. Jamal is at 0, 0. But let's say I want the number at 2, 1. Who's at 2, 1? Luke. Row 0, 1, 2. This is column 0, column 1. This is actually the very last item in the array, right? So if I print this out, I should get Luke. Okay. Who is at 1, 3? Who's at 1, 3? No one is. That's too far. I went over the bounds. I went over the edge. There aren't 3 columns. There's only 2 columns, and actually 3 is even, a little bit extra bad, right? The last address for a column is 1, 0, 1. So I couldn't even do 1, 2. 1, 2 is not allowed either. If either one of these numbers is too big, the whole thing is going to crash, right? And you're going to see this. You're going to see this type of error message. Don't get discouraged. Take a look at the problem. Take a look at where it happened. Click on this button. It'll take you to where it happened and see if you can figure out why it happened. See if you can fix your code. That's programming. I spend far more time fixing problems than I do writing code from scratch. I guarantee you. Guarantee you. A good programmer, in my opinion, is someone who can solve problems, fix things, not someone who's going to crank out a pristine program on the first try. That doesn't happen. That's unrealistic. It's not a realistic expectation. People make mistakes. It's just part of who we are. A good programmer is one who can solve problems. All right. So let's talk about then, what is this example? Do I want to do? No, I don't want to do that example. Let's talk about traversing a two-dimensional array. And this is another great one to kind of work through the debugger a little bit. In this program, I'm trying to, well, actually, it asks us what it's going to print. And we'll use the debugger to see if we can kind of figure it out, since for a lot of you, this is a very new piece of code, a very new way of thinking about things. We've got 2 loops here, and one of the loops is inside of the other one. We saw that last week. What do we call that when a loop's inside of a loop? Nested. Good. Nested. Got a nested loop situation. That means that this loop is going to run this many times, whatever that is. Yeah, question?
Yeah, when we're doing nested loops like traversing 2D, right, are we always going to do row first?
That's a great question. The question was, when we do nested loops like this to traverse arrays, are we always going to do rows first and then columns? You are a little bit ahead of me. I was just about to point out the fact that, yes, we do have one loop for the rows and one for the columns. That is true. Do we always do rows first and then columns? No. Actually, that is not true. There might be situations in which I would want to do the column first followed by the row. However, this is by far the more common way of doing it. So I'm going to do it, this way 90 times out of 100 probably, if not more. Yeah, great question. But kind of back to just the process at hand. I do have one for the row and I do have one for the column. And also notice, we've seen this before. This is what tells us how many rows there are. This is what tells us how many columns there are, right? So I'm asking, this is almost like a formula in my mind if I need to traverse a two-dimensional array, which means visiting each element of the array, right? I'm going to need to know how many rows there are in that array and how many columns there are in that array. I'm going to need to know that information. And this is how we access that information. This is how we ask the array to tell us how many rows it has and how many columns that it has. So one thing to think about is, okay, we have these two loops. What is the value of row and column going to be over time? This is another great one to run through the debugger. I'm going to set a breakpoint inside of the loop on line 13. Yeah, 13. That's a good. You could set it a little earlier if you wanted to, I suppose. I'm going to start on line 13. And the two values that I'm interested in looking at right now are these two. Row, which is the loop variable for my outer loop here, and column, which is the loop variable for my nested loop here. So column, being the inner loop, that's the one that is going to spin faster, right? It's the one that's going to change more frequently. So I'm going to see row remain constant while column counts up. That's how nested loops work. When I step through this code, I don't care about the arithmetic. We'll take a look at the arithmetic in a moment. I care about row and column. So I made it through the loop. Column went up 1, but row remained the same. And the next time through the loop, column is 2, row is still 0. Row has not changed yet, right? Only when I get to the end of the row am I going to see row goes up now to 1 and column now gets reset back to 0. So how am I traversing this loop? If you had to picture in your mind, right? I've got my rectangle. Where do I start? Where am I starting at this rectangle? I'm starting at 0, 0, which is top left. That's what I said before. And how am I actually, what's the motion that I'm making through this? Row stays the same, column goes up. So I stay on the same row and I move to the right. I get to the end of that row. Row goes up 1, so I move down, and then I set column back to 0, and then I keep counting up until I get to the end of that row. It's from left to right, top to bottom, just like we're reading a book. Just like you would read a book. Same motion. Go through the whole top row, move down to the next one, go through the whole next one, move down to the next one, move down to the next one, so on and so forth. So here we see I go through and take a peek at row number 1, and that's actually it. There's only 2 rows. And so at the end it prints out some stuff, and that's kind of our next task, is to figure out what the heck this actually represents. Maybe some of you have already figured it out while I've been up here talking, but before we talk about what that number is and what this code is actually doing, just want to see if anybody has any questions just specifically about this part. How we're traversing this array. I'm spending a lot of time on this because for a lot of two-dimensional array problems, notice I didn't say all of them, but a lot of them, this is going to be a necessary part of the problem that you're solving. I write this kind of loop all the time. You're going to see me actually probably write this kind of loop, these kind of loops again and again. Definitely next week. People like to ask me about these kinds of problems, as you can imagine, in preparation for the exam. But even after that, I'm still going to be using this style. That's part of programming, is recognizing, you know, when you've got the right tool for the job. For 2D arrays, nested loops, they go hand in hand a lot. There are exceptions. This isn't what you want, this isn't what you need. But a lot of the times, yeah, nested loops, 2D arrays, they go together really nicely. So, you know, keep this in mind. Another thing to think about, I actually maybe should have touched upon this earlier, but using these inside of your loops is so important. I could try and do something like this, right? If row is less than 2 and column is less than 3, that's how many rows and columns there are, right? I can see right here, there's 2 rows and there's 3 columns. So why not just put the numbers in there? Why am I going through all this extra effort to say, you know, a.length, a bracket 0.length? Well, keep in mind that I can always come up here and do something like this. And now there's an additional row, right? There's an additional row. And if I had this permanently set to be 2, in computer science terms, we would say that's hard-coded, right? Hard-coded as 2. It's always going to be 2. That's usually a bad thing. That's usually a sign of sloppiness, because we can always ask the array directly how many rows it has using a.length. This code will work even if I change the array up here. Hard coding in a number like this will only work in a very specific situation and will not work in others. And the way that it doesn't work won't even be consistent. Sometimes I'll get that red text that says I've gone too far. Other times I'm going to stop too early, and I might think that it's working, but the number's wrong. Both are bad, right? Both are undesirable places for me to be. So yeah, definitely try to keep this as general as possible. What questions do you all have? Any questions that I can address? Yes?
You said the 7, 8, 9 would be read as a row.
That's correct. Yeah. This has to do with the fact that our arrays are in row major order. You could think of these as being columns instead, right, if you wanted to, but that'll never happen. We always treat them as rows. Rows first, then columns. Always, 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 always. Yep. So let's take a look and see if we can't figure out what the heck this code is doing. And why not use the debugger to help us with that, because the debugger is such a useful tool. I know that I left that extra row in here. It doesn't matter. We can still figure out what this code is doing, even though I changed the data a little bit. So my breakpoint's still set. That's good. First thing that it's going to do is it's going to extract a value. Which value is it going to extract? It's based on the loop variables. So notice that I have the row plugged in as the row index and the column plugged in as the column index. This will always be the row. Always, 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 always has to be the row that you want. Always. Getting those two things flipped is a common mistake. And, you know, something to take a look at if you get one of those array index out of bounds exceptions, for example. So we're going to extract that value out of the array. First time through, I can see my row is 0, my column is 0, and we can even use the debugger to look in here, right? This is row 0, this is column 0, there's the value of 1. So my value should be 1, and it's going to add it up. It's going to add it to this total, which is, you know, currently 0, it is now 1. Then I'm going to go through the loop, and I'm going to add the next value at position 0, 1. Okay. That gets added. We're now at 3. And I already kind of feel like I have somewhat of an idea of what's going to happen here. I don't feel like I need to step through all of this code necessarily to get a feel for what's going on here. I can see that these loops are going to visit every single element in my 2D array. This code appears to be summing them up, just adding them up. So it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So it's going to add them all up, and then it's going to divide by this guy right here, which is the, what is that? Total number of elements. Yeah, number of rows times number of columns would get me the total number of elements in the array. That's right. Or the area, right? If you're thinking about it in geometry terms, two-dimensional, right? So the total divided by the total number of elements, this is computing an average. It's computing an average. This code is computing the average of all of the numbers in the array. That's what it's doing, right? It's using this value to compute the sum, and then dividing by the total number of elements at the end, just like we would compute the average. This is actually another very common pattern. It's such a common pattern that we have a name for it. This last part is not technically part of the pattern, although it's also very commonly used. But you know, this part of the pattern here, specifically the act of keeping this running total, that's what this is, right? It's a running total. Or in computer science terms, we would say this is an accumulator pattern. We're letting those values accumulate in the total variable. So we actually see this pattern over and over and over and over again. And probably we'll see it when we do some exam review problems next week. As a matter of fact, you might see it in your studio this week as well. As a matter of fact, accumulator pattern is a very, very, very common one that you see in a lot of computer science problems. All right. Any questions for me? I got one more example for you before we call it a day. Somebody earlier asked me if we always see the row first in the arrays and then the columns. And I told that person the answer was no. Here's an example doing just that. But think about what this means. And actually, I want to pay close attention to this part right here. Notice that even though I switch these loops, I cannot switch these two, right? That's not possible. These are positions within the array. This will always, 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 always be row first. Always. Always. Has to be. So think about then, what is actually changing about this? If this part's always row first, then what actually changes when I switch those two loops around? Well, before we saw that the row remained constant while the column counted up. Since I switched those loops around, now the column is going to remain constant while the row counts up. So think about the motion. The way that I had it before, I was doing left to right, top to bottom, just like we read a book. But now I'm holding the column constant while I move the row. I'm going down. I'm going down each column. This is what we would call a column order traversal. So we can actually run this through the debugger as well, just to see for ourselves, right? Oops. That was the last program. This is the program that I want. All right, here we are. We're on line 10. No? Let me start it over again. I think I did the wrong program, maybe. All right. Here we are on line 10. And column is going to stay constant this time while row counts up. So there's the value at 0, 0 that gets printed out 1. We're going down the columns. So column 0, row 1 would be the 4, correct? Would be the 4. Column 0, row 1 would be the 4. Or row 1, column 0 might be the more appropriate thing to say. Now we're going to bump column up 1, and we're going to do it again. Row goes back to 0, so I'm at row 0, column 1, that's going to give me the 2, and then the 5, and then the 3, and then the 6. So instead of going left to right, top to bottom, I'm now going top to bottom, left to right. And if I just run the whole thing, you can see that for yourself, 1, 4, 2, 5, 3, 6. It's going down the columns. Again, this is something that we want to do sometimes. But more often than not, we want to do things this way. That row major order of our 2D arrays is pretty strong. Also, we as humans just like thinking about our data, left to right, top to bottom. Go figure. That's what we like. So we write our code to match that spec. Cool. I think I've thrown enough information at you for one day, so I'm going to go ahead and leave it there for now. Be happy to stick around if you have any questions. Otherwise, I'll see you in the labs. Have a great week, everybody.